Well, first, thank you for coming.
Yeah,
um,
glad to be here. Yeah.
and I'm gonna say some basic stuff first, so you can just to go over basics. And so if you know it, that's fine. And I hope you do know some of this stuff, but it doesn't really matter if you don't. We'll start at the basics anyway. So here's a line. Da, da, da. This line, let's call it energy. Okay, so let's call it current. Let's call it like say something's plugged in here and something's plugged in here. When energy flows through this line, there's going to be created an electromagnetic field that spins around the line in a clockwise direction. So it looks like that, but a little crudely, but more from the front, you'll see it, and the line will go side to side. Okay, and that's the magnetic field. This is the electric field. So the electric field generally is drawn like this. And they do that because it's a waveform. And so here's 0 point. And it could go above and below the wave, or it could be 0 point here, which is mostly a DC current, right? So a
Mhm.
DC current goes up and goes to zero, and then goes up and goes to zero. And an AC current will have zero here, and will go this way, and then that way, and then this way, and then that way. So that's why they call it an alternating current versus a direct current. So an AC current is going to have the alternating current, and that's going to be alternating as in it's on one side and then it's on the other. And that oscillates at what's called a Hertz frequency. And that Hertz frequency is going to be 50 to 60 Hertz. Generally, we try and get it at 60 Hertz. Generally, it's not there, but that's what we're shooting for. So our AC current's 60 Hertz, which means that it goes between here and here 60 times in a second, or 60 times in a minute, in a revolution. I'm sorry. Uh, and so uh, it's going to go through 60 times a second in each revolution of the Hertz frequency. So it's AC currents goes one side to the other, one side to the other in milliseconds. And then to us, it seems inconceivable. It just seems like constant electricity.
Mhm.
Um, this is an electric field. It causes a magnetic field around the wire. So when you run a wire, spiraling around the center. So if we imagine now this is the center of a wire,
Mhm.
all around the outside of it is the magnetic field.
Mhm.
So magnetic field is just spiraling on the outside as the current runs through. And so the way electricity works is it all goes to the path of least resistance. And it also works in both ways. So a speaker can be a microphone, and a microphone can be a speaker. And so because of that, there's two ways of messing with the electromagnetic field, through the electric field or through the magnetic field. So if the magnetic field's going around a wire, and the magnetic field is, say, doing this, and the electric field then is the one that we're trying to activate, then there's no electricity running through the wire. What we can do is move a magnet over the wire, and that creates energy. That's how wind generators work. That's how motors work in reverse, electric motors. And that just shows the way that electricity and magnetism are intimately related and connected. Um, and we call it electromagnetism, but it really is two separate forces. And they directly correlate to each other in symmetry. And so if I give it a magnetic field, it's going to equal that magnetic field in electric field. And if I give it electric field, it's going to equal that field in magnetic field. Why is that important? Is that everything is a two-way street. So now we have the option of what are we going to do with that? What are we going to do with all this information? So one thing we can do is, like I say, a wind generator. We can move a magnet back and forth over a line, and by moving that magnetic field around the line back and forth, we create energy in that line. And the energy creates a current and it flows in one direction.